So after discussing about various strategies adopted by designers or engineers for using percentile anthropometric data, now we are moving to next slide where some important points are mentioned. So first one, use of specific percentile data. For example, 95th percentile data may accommodate same percentage of people or same percentage of people population. So as we discussed about the example of door height, so if we talk about door height, so if the height of the door is decided as per the height of 95th percentile person, then obviously 95th percentile person will be able to go through that door, while 95th percentile people with 95th percentile standing height or stature is able to go through this door, then others whose height is less than 95th percentile, so they will also be able to go through. So if this height of the door is decided as per the height of 95th percentile stature, 90th percentile stature, then what will happen? Not only that particular person, but all others whose height value is less than 95th percentile, all of them will be able to go through. So using 95th percentile anthropometric data in this particular case is allowing 95% of the population to use that particular facility or particular design. If we come to the next point, use of a specific percentile data, say 5th percentile data, does not mean that it will accommodate the same percentage, mean 5% data. We also discussed about the example of door latch. While we are positioning a door latch on the door, so this is the door latch. While we are positioning this door latch, and for that purpose we are using 5th percentile arm reach value, then what will happen? Not only 5th percentile, so in this case for positioning door latch, we are taking the anthropometric variable vertical arm reach, and we are also using the 5th percentile value. While we are using 5th percentile value, then not only this 5% population, but 95% of the population whose hand reach value is more than this 5th percentile value, all of them will be able to access this door latch. It means although we are using 5th percentile data of vertical arm reach for positioning this door latch, actually we are allowing 95% of the population to use the facility. So use of 5th percentile data does not mean that only 5% people will be accommodated. It means using 5th percentile data actually accommodating 95% of the population. But in the earlier case, we are using 95th percentile data, and we at the same time we are accommodating 95% of the population for that specific design dimension. Now, in another case, if we use two extreme percentiles, say 5th percentile and 95th percentile data for any facility design, then what percentage of the population will be able to use that product or facility? So in this case, we can take the example of height adjustable chair. If height adjustable chair or height adjustable table, if this table surface can move up and down, starting from the while we are seated like this way. If this is the elbow rest height, this is the design dimension, that is the table top height. For that purpose, corresponding anthropometric variable is elbow rest height. If we use starting from 5th percentile elbow rest height to 95th percentile, then in between these two 5th percentile to 95th percentile, the whole 90% population will be able to use comfortably. So using 5th percentile and 95th percentile data for a particular design dimension, then actually we are covering 90% of the population. So from this three, what we can conclude, using a specific percentile data does not always mean that we are accommodating that particular percentage of the population. We may use 5th percentile data, but actually we are accommodating, in this case, 95% of the population. On the other hand, we are using 5th percentile and 95th percentile data for the same design dimension, and we are accommodating 90% of the population. So we can mention in this way, while we are using a specific percentile anthropometric data for designing a specific dimension of a product or facility, then we are accommodating in different situation different percentage of the population. Sometimes it may be 90%, sometimes it may be 95%, sometimes it may be some other percent. So we have to understand that which percentile, use of which percentile data actually accommodating what percentage of the population. Designing, so if we read this one, designing any facility using 50th and 90th percentile anthropometric data, only we can ensure that the facility would be compatible to a wide range of people. We cannot mention any specific percentage of the population, as any single facility consists of various design dimensions. So in earlier case, while we will discuss about this chair dimension, then we discussed that for different parts of the chair, if we talk about the seat pan height or seat pan width or seat pan depth, for that we use different percentile of anthropometric data for different design dimension. So if we mention we have designed this seat width as per 90th percentile hip depth, and if we say that the whole chair will be used by 95% of the population, it is not possible, because for different design dimension we need to consider different percentile of anthropometric variable. That's why we can never mention that we have designed any facility only using 5th percentile anthropometric data or 90th percentile anthropometric data, because different dimension of that particular product requires different percentile of different anthropometric variable. So not only that, say some facility has been designed as per the height of 95th percentile person. First, this chair has been designed. If we take the example of chair, we have designed the seat height of as per the 50th percentile popliteal height. Then how we will mention that only 50% of the people will be able to use or 90% of the people will be able to use. We cannot specifically mention, because even for a single individual, all the body dimension may not be of a particular percentile value. If we take the example of this door height also, for this particular person whose head height or stature is 95th percentile, he can go through this one. But if we consider other variable, say for example for this door width, also we have used 95th percentile body breadth or shoulder breadth. For door width also we are using 95th percentile shoulder width. So in that case, this person, his height or her height is 95th percentile, but his shoulder width may be more than 95th percentile also. In that case, if we design this door width as per 95th percentile shoulder breadth of that population, that particular person will not be able to use that door, because it is matching with his stature or vertical height, which is 95th percentile, but his or her shoulder width is actually more than 95th percentile. So it is not possible for that particular person to go through that door. So that's why this statement is very important, that using 50th or 95th percentile data, we can only mention that wide range of the population will be accommodated, but we never can mention that it will accommodate a specific percentage. We cannot mention 90% or 50% or some other percentage, because so many other factors are also associated with this. Any single product or facility comprises of so many variables, design variables, and for each design variables there is requirement of corresponding anthropometric variable, and out of that anthropometric variable which percentile we need to use, we have to decide that one. Now after anthropometry, after discussing about what is anthropometry and how to use percentile anthropometric data for different types of facility or product design. Now we are moving to biomechanical data. So first, what is biomechanics? Biomechanics, actually we can define as the mechanical property of biological system. Our human body is a biological system. As it is a biological system, so if we consider or if we discuss about the various mechanical property of that system, then that can be mentioned as study of biomechanics. Under biomechanics, we discuss about musculoskeletal system, skeletal linkage system, as we have already discussed in our earlier slides, that human body is made up of various bones and joints, and we can represent human body like this type of linkage segments. Second, body joints location and range of motion. For each of the body joint, range of motion is also different. And also that range of motion varies from human to human. For me, if this flexion extension of elbow joint, for me if it is 120 degree, for someone it may be 130 degree. So range of motion is also different from person to person. Then degree of freedom. Each body joint also have different degree of freedom. First, if we consider shoulder joint, then shoulder joint has 3 degree of freedom. One is abduction adduction, this in this direction. Another is forward backward, this is flexion extension. At the same time, rotation is also there. So 3 types of degree of freedom is there for 3 degree of freedom for shoulder joint. Similarly, if we consider the elbow joint, in elbow joint only we can find 1 degree of freedom, that is flexion and extension. Then comfort range of motion. Although for this elbow joint flexion and extension is happening, this is the total range of motion. But out of the total range of motion, the whole range of motion is not comfortable for working. So only this mid range, where we are mid range of the motion of the elbow joint is considered as the comfortable for sustained for prolonged activity or for working at various types of tasks. So out of the total range of motion, we need to define also the comfort range. Out of total range of motion of the body joint, we have to define a specific joint, and if for a particular joint, say elbow joint, if this is the total range of motion, then we can mention if we consider this is 0 degree and this is say 120 degree. So within this range of motion, we are mentioning only this mid portion 0. So 80 degree to 110 degree, within this range it is comfortable. Then there is muscular force exertion. For various types of knob operation, pull push force, pulling, pushing, or for performing different types of activities, we need to exert our muscle force. So that is also discussed under biomechanics. So here is one example where we are measuring the leg force or leg strength at a particular angle of this knee joint, that is 130 degree. At 130 degree angle, how much one individual can exert the force, vertical downward force. Similarly, as I mentioned, for different body part joints, the range of motion is also different and the degree of freedom is also different. So we can go through this type of information where the range of motion of different body parts are defined, and for this purpose also there are different database for different population. Population to population, range of motion varies. Although the degree of freedom is same, because for a human body joint, for a particular joint, degree of freedom is fixed. It may be 1 degree of freedom or 2 degree or 3 degree, but it is same for all individual. But the range of motion is different from individual to individual as well as for population to population. So here is a sample of range of motion data adapted from Kroemer et al. 2010. So here this is the 5th percentile, 50th percentile and 90th percentile data for different body joints: neck, ventral flexion, dorsal flexion, right rotation, left rotation. So for this joint, neck joint, this type of flexion, dorsal or ventral flexion we can mention as this is flexion, and dorsal flexion we can mention as extension also. So flexion, extension or rotation data, it is tabulated here. So we can calculate. So for a particular population, we can measure the range of motion for a particular body joint, and after measuring the range of motion data from a good number of subjects, after collecting from a big sample, then we can calculate various percentile, 5th percentile, 50th percentile, 90th percentile, or any other percentile as per our requirement. So this data base then we use for different facility design. Say for example, we want for opening the door, how much force should be exerted. So obviously in that situation we should use 5th percentile force exertion data, push force exertion. So while if we have the database for a particular population for push force data, right hand push force, then what we can do, from that data we can identify the 5th percentile value, and accordingly with the 5th percentile push force data, if we design or if we determine the what should be the actuating force for door opening, we can use that 5th percentile data. Similarly, in some other situations, say for example 90th percentile data or 50th percentile data. So as per our requirement, we have to use that one. Some other door where entry is restricted, so for that purpose we can go for higher percentile of pull or push force, because it is not for easy access. So actually what we discussed, that is about pull push force data, but here sorry for this mistake, this data was related to range of motion for different types, for different body joints. This is the range of motion data. Similarly, this is the data for push pull, different types of force data. For different body segment or body joints, we can measure the pull push force in different direction. So in this picture it is shown that in various direction how much hand pull force we can exert. So this data actually adopted from Morgan et al. 1972. So in this way, for designing any facility, while we are thinking about the range of motion for operation purpose, if we want to operate a knob, want to open some, or there is a moving machine part, how much that operator has to move that button or move that control from one point to another point. So what should be the comfortable range of movement of his hand? So that we need to decide. So if we design that facility as per 5th percentile range of motion, then what will happen? All other person whose range of motion data is more than 5th percentile, everybody will be able to use. 95% of the population will be able to use. So for this purpose, if we use 5th percentile range of motion data for some moving parts of the machinery or moving parts of the control, then that will be very much usable for wide range of population. On the other hand, if we go for this is range of motion data. Similarly, if we go for force data or muscle strength data, in that case also, as per our requirement, we can use various percentile data, 50th or 95th percentile. It will be much more clear if we take a specific example, case example. So in this case, this is also on sample data. This is adopted from Gitte et al. 2009. So this is the database for Indian agricultural worker. So this is a female agricultural worker. So it is showing that leg strength of right leg sitting in that situation. Leg strength measurement is going on. This is for male person. The same. This is for right leg strength data. So for this purpose, for different states of India, the data has been collected both for female as well as for male, and it has been tabulated as in different percentile, mean, standard deviation value, and 5th percentile and 90th percentile value. So this data can be used for designing various types of agricultural tools and equipments. Now if we take a specific example, say actuating force limit for some important tractor controls for Indian male agricultural workers. So in that book, Gite et al. 2009, they have shown that how percentile biomechanical data, I mean percentile strength data, force data, we can use for deciding the actuating force for different tractor controls. If we think about the brake pedal, so brake pedal is operated by right leg. Now, which percentile data should we use? We have the database where leg strength data for right leg is available. Out of that database, we will take 5th percentile right leg strength data for male, because generally in Indian scenario, tractor is being driven by male only. So 5th percentile right leg strength is 261 Newton. So maximum actuating force for operating this brake pedal should not be less than 260 Newton. If it is less than 260 Newton, then what will happen? With just minimum force, why unintentional brake will be pressed. So its minimum value should be 260 Newton. Obviously, all others whose force capability is more than that, they will be able to operate that one, use that brake pedal, because their right leg strength is more than this 5th percentile value. So 95% of the population, male agricultural worker, whose right leg strength is more than this 261 Newton, all of them will be able to operate the brake pedal. Similarly, for clutch pedal, clutch is operated by left leg. So 5th percentile left leg strength data for male agricultural worker is 247 Newton. And this control is frequently used. For that purpose, instead of using 100% strength, we should go for 50% of left leg strength. That is half of this, 247 divided by 2. So it is coming 123.5 Newton. So as clutch is operated frequently, so 5th percentile leg strength data is 247. Out of that, only 50% we will consider. So that is coming 123.5 Newton. For that purpose, so maximum actuating force for clutch operation should be less than 124 Newton. So if clutch pedal operation force is 124 Newton, then obviously all other person whose already we have considered 5th percentile, so 95% of the population can use that one. As it is frequently used, again we have deducted it by 50%. So actuating force in this case is 124 Newton. Now next, gear selection. 5th percentile hand push strength is used, that is 49 Newton. So maximum actuating force in this case will be less than 49 Newton. Similarly, accelerator pedal, 5th percentile right foot, because accelerator is operated with right foot, so that is 5th percentile data is 163 Newton. Continuously operated, so we can use 30% of that. In earlier case you saw that there was 50%, now it is 30%. 5th percentile of right foot leg strength data is 163 Newton. As it is continuously being used, so we will use 30% of the 5th percentile right foot strength, that is 49 Newton. That is the upper limit. Now maximum actuating force for accelerator operation, the same we can mention as 49. Now weight of the leg, is 9% of the whole body. If whole body weight is 54.7 kg for an average person, and 0.9% of that is the weight of the leg, and this is the G value, gravitational force, gravitational acceleration, and 0.5 is the, if we consider half of that, so 24. So lower limit, so only the weight of the leg, due to the weight of the leg we can exert, and we have considered 50% of that, that is that's into 0.5, so 24 Newton. So its lower limit will be 24 Newton, whereas the upper limit is 49 Newton. So upper limit is decided based on the 5th percentile right foot strength, and it's 30%. But lower limit is decided as per the weight of the leg, that is the 0.9% of the whole body weight into gravitational acceleration into 0.5, means we are considering 50% of the leg weight. So it is coming to 24 Newton. So during deciding the actuating force for accelerator pedal, we have to set our limit, maximum 49 Newton and minimum is 24 Newton. Similarly, we can also decide the steering wheel torque. Regional variation and gender variation of isometric strain data are crucial for ergonomic consideration for using percentile strain data. So Patel et al. 2016 mentioned that it is very important to use regional strength data for various types of facility. Particularly in this case, he gave the example of agricultural tools, but in general, regional isometric strain data is very much important for various product or facility design, because from one area to another area, due to ethnic variation, due to geographical location variation, strength of the human being varies. For that purpose, we cannot blindly adopt some equipment or tools from specifically developed from one region, directly cannot adopt for another completely different geographical region, where the population is completely different, their strength data will also be different. Now, key learnings from module 2. So far whatever we discussed in module 2, so first we have discussed, if we recapitulate, so these are the key learning. So we discussed percentage and percentile, how percentage is defined from percentile, how to calculate various percentile data, the measures of central tendency, then what is standard deviation, what is normal distribution, what is normal graph, from normal graph how we can define, how we can calculate various percentile data. At the same time, why for various design purpose we use 50th and 95th percentile data, we discussed. Here specifically we highlighted that with one standard deviation we can accommodate 68%, but if we increase that little bit from one standard deviation to 1.64 standard deviation, then actually we can accommodate 2% extra. But beyond that, that increment is less, so we will not go for that one. We will restrict ourselves at this level. So we will consider for our design purpose, we will use 5th percentile to 95th percentile data to accommodate 90% of the population. Similarly, we discussed about the body planes, landmarks, then our vertebral column structure of the little bit anatomy of human body. Then we discussed about the anthropometry, what is anthropometry, what is biomechanics, then various types of anthropometric data, its percentile calculation, biomechanical data, with percentile biomechanical data, its use for design purpose, and also we took the example of how percentile anthropometric data is used for this type of bench design, where so many people, multiple users are there. At the same time, how we can use various percentile anthropometric data for designing a facility like chair. Then what strategies are adopted by designers or engineers for using percentile anthropometric as well as biomechanical data. Then we discussed about all this. Then we took the example of this particular tractor controls and how we can use different types of strain data. So overall key learning from this module 2 is basic statistics for understanding the percentile calculation, normal distribution, normal curve, anthropometry and anthropometric data. We mentioned why we use mainly we prefer to use 50th and 90th percentile data for various design purposes. Then how we use percentile, anthropometric and biomechanical data for our design of product and various types of equipment or any other facilities. So this is the list of references. So all these references has been used for this presentation. So students who are going through this particular course, they can explore all these references, so they will get more insight about this subject. Not only those references, apart from those references, in module first also, I give this type of useful online resources. So you can explore all these online resources where you will get enough information regarding overall ergonomics, anthropometry, biomechanics, and not only that, if you say this type of humanics ergonomics, in this case we will find various databases from various countries, anthropometric data, biomechanical data. So all those data will be available from this type of site. Apart from that, I also suggest you to go through these two, specifically these two resources. Ergonomics lab for assessing physical aspects of design. You can explore this one, and also engineering design, ergonomics for beginners, industrial design perspective. So these two resources are also very helpful for the students and also beginners to understand the subject ergonomics and various ergonomics aspects of product design. So thank you. This is the end of module 2.